From 15, we have f of x, x squared plus 2x. They're giving us x1, 3, and x2 equals 5. And they want us to find the average rate of change for this function between x1 equals 3 and x2 equals 5. I have the formula right here, but I'm going to write it one more time. So the average rate of change between 3 and 5 will be f of x2 minus f of x1 over x2 minus x1. Good. So I will do x2 minus x1, which is 5 minus 3. But what do we put in for the top? Can anyone tell us how do I get f of x2 and how do I get f of x1? Of course, thank you very much. Of course. So I have to find f of 3. And I have to find f of 5. Can anyone give us f of 3? Yes, it's 9. So it's 9 plus 4, right? It's 10, right? 3 squared is 9 plus 2 times, no, it's, what is it, 15? So 9 plus 6, 15. Is that correct? Okay. So now with 5. 25 plus 10, 35. Perfect. So then the numerator is 35 minus 15. So then the top will be 20. The bottom is 10. But the bottom is 2, and the answer is 10. If the numerator is distance in miles and the denominator is time in hours, what will be the measurement unit for 10? Yes, if the numerator is distance, miles, and the denominator is time in hours, what will be the measurement unit for 10?
Miles per second.
Of course, miles per hour, of course, right? Because it's a rate of change, it's a ratio, so its measurement unit must be a ratio. The top measurement unit comes from the numerator, and the bottom measurement unit comes from the denominator. Is that correct? Is that clear? Okay. The last section before our test. Yes, please. Yes, yes.
The top one, is it 15?
Say it again.
The top f of 3, is it 15?
3 squared is 9. 2 times 3 is 6. 9 plus 6, 15.
Oh, okay, I thought it was 10.
That's okay, because that's what initially I said that. It's my error. I'm sorry about that. Yes, please.
I'm sorry, for f of x2 minus f of x1 over top of x squared minus x1.
x2 minus x1.
I'm sorry. X2.
Correct. Yes.
Was that generally like the formula you use to find the average rate?
It's the slope of the tangent line. It's the slope of the segment line. The slope of AB is the average rate of change. So rise,
Right, okay.
y2 minus y1, run, x2 minus x1. But this time, the rise is mentioned as f of x2 is presented as f of x2 minus f of x1. But it's y2 minus y1.
All right, yeah.
Exact same formula from before. Very good point. Other questions? Okay. So the very last section before our test next Monday is 2.5, which is transformations. Say it again. Anything else?
Wait, so I just covered everything again?
Yes, and this is the last section. This is the last section. Say it again. You're not getting a heart attack, not in this class. No. Okay, so transformations will enable us to understand the function better, number one. Number two, it will help us graph a function quite quickly, and it will help us create a model for data that we may be able or may be interested in looking at. However, transformations mean nothing if we do not remember graphs of very, very simple functions. So we're going to list them first and then look at transformations. So I call them basic or base functions. They are the simplest possible functions in certain categories. So polynomial will be a category with 4 different basic functions, the simplest possible functions. Linear, quadratic, cubic, and 4th degree. So the simplest possible polynomial functions in the category of linear, quadratic, cubic, and 4th degree. So let's see. Can anyone give us the simplest possible linear equation? So let's start with linear. We have about 7 different graphs. So 1. Can anyone give us a simplest possible linear equation? That's way more complicated than I expected.
2x3 plus
That's way more complicated than I expected.
1.
What?
X plus 1.
That's even way more complicated. The simplest possible linear function is plain x. There is nothing else. Plain x. Very good. You're on the right track. I'm happy. So here's the graph. We have to remember this. So this is f of x equals x. Please tell me odd, even, or none of the above. Very good. Symmetric with respect to the origin, that is an odd function. Perfect. Now please give me quadratic. Give me the simplest possible quadratic equation of, quadratic function that you can ever think of.
X squared.
Of course. No, that's way more complicated. We're talking about base function. The simplest possible quadratic function is x squared. Here's its graph. And please tell me odd, even, or none of the above. Of course. Of course it's even. Symmetric with respect to the y-axis. Awesome. Thank you. Good. Number 3, cubic. Can anyone give us the simplest possible cubic function that you can ever think of? Of course, you got the drift. So here's the graph, and we used it before. When we illustrated, do you remember what we illustrated? Let me graph it for you. And you'll tell me what we illustrated with this. What did we illustrate with this? Exactly. Which one is it? Odd, even, or none of the above? Of course.
Excuse me.
Yes?
How do you get it all evening? Why you getting it?
He wasn't here then.
He wasn't in that class. I see. I see.
I'm missing.
Okay.
I'm definitely missing.
Okay. Okay. Here's what we did.
No,
Okay.
let's go ahead. I'll catch up. Well, I'm just confused where you get from it. That's all.
Okay, so let me just quickly, because other students missed that class too. So what we did was we connected a point on the graph with a line segment going through the origin. And of course, it will be extended and connect this point. So this piece between this point and this piece equals this line segment. And then we said, okay, if this is negative x and this is x, obviously this is f of x and this is f of negative x. As you see, this number, if this number is 5, what is this number?
-5.
Correct. That's why this function has to fulfill this condition. F of negative x is the opposite of f of x. F of negative x equals the opposite of f of x. So that's how we get it to be odd. Symmetric with respect to the origin. In other words, what I have in the first quadrant, I have a copy in the third. Okay, fourth degree. Can anyone give us a fourth degree function? The simplest possible fourth degree polynomial function. Absolutely. So here's the graph of x to the fourth. It's a little bit flatter. We're going to talk about this function in the next chapter. So this is f of x equals x to the fourth. And I would like you to tell me odd, even, or none of the above. Of course. Same thing with x squared. We have 3 more functions to look at. 5. Now you'll tell me square root, which is the simplest possible square root function. Perfect. So here's the graph of the square root of x. Odd, even, or none of the above. Of course, this is not symmetric. It's not odd, it's not even, not symmetric. 6 and 7. F of x equals the cube root of x. So the simplest cube root. So here's the graph of the simplest cube root. Here it is. Odd, even, or none of the above? Very good, awesome. And the last one, can anyone give us the simplest possible absolute value function that you can think of? Absolutely. And we graphed it a long time ago. What did we say? It looks like a... Indeed, thank you very much. Awesome, well done. Indeed. Odd, even, or none of the above? Very good. So that's more than enough for now. 7 functions. Yes. Any questions?
7 functions for what again?
7 functions, the simplest possible functions. 4 polynomials, 2 roots, 1 absolute value. That's it. Simplest possible. Without these, we cannot illustrate transformations. Okay, ready? So transformations. This is 2.5. Ready? Good. So here they are. Shifts of 2 types. Horizontal, vertical. Shifts, 2 types. Horizontal and vertical shifts. Reflections of 2 types. Reflections, 2 types. With respect to the x-axis and with respect to the y-axis. X-axis, y-axis. And the last one, stretching / shrinking. Of course, vertical and horizontal. Okay, a total of 6. So this will be number 1, number 2, number 3, number 4, number 5, and number 6. So let's start with number 1. Okay, I'm going to create 2 functions. f of x, and I'm going to create g of x. The first function I'm going to say is x plus 3 in absolute value. And the next function is the absolute value of x minus 1. Here's my first question to you. Which function did I pick from that list of 7? Which function did I pick to create f and g? Of course. I used the basic function, right? We agree? I used the absolute value of x, correct? Once I said the absolute value of x plus 3, I must have used the absolute value of x. Okay. Now my question to you is, let's just compare this to this. Disregard the g of x for a moment. Just compare these two. This one, the basic function is the absolute value of x. But this function is the absolute value of x plus 3. What did I change? Well, the answer is I changed x into x plus 3. So by making that change from x to x plus 3, I am shifting the graph horizontally, either to your left or to your right. But the graph has to stay on the x-axis. Cannot go anywhere else other than right shift or left shift. Left shift or right shift for you. Okay. So this was initially at 0, 0. Since it has to stay on the x-axis, where will this graph go? Will it go to your left 3 units, or will it go to your right 3 units? And think for a moment. Do you all agree with your left? It has to stay on the x-axis. If I say to the right, 3 plus 3 will go up somewhere. Right? We're talking about horizontal shift. We are changing x. You are way ahead of me. So for x equals 3, 3 plus 3 will be 6. Right? But y will not be 0 anymore. 3 plus 3 is 6. But y is not 0. It's 6. When x is 3, y is 6. So this cannot be a right shift. It has to be on the left, going to the left, because it has to stay on the x-axis. So that's why this is a horizontal shift of 3 to the right, to your left. So 3 left. What about this one? This will be a right 1. So right 1. Yes, go ahead.
Are we just trying to make it 0?
Because the absolute value of x at the origin is 0, 0.
Okay.
So I am shifting, I'm changing x into x plus 3. Obviously, this graph will shift to your left 3 units.
Gotcha.
It's a horizontal shift.
We should close the negative direction.
If you want to consider negative direction, but it has to be such that it stays on the x-axis. By staying on the x-axis, meaning y still has to be 0. If it's a horizontal shift, the graph doesn't go up and down, correct? Joe, go ahead. Go ahead. So if it's a horizontal shift, and that's what it is, I'm changing x into x plus 3, the graph does not go up or down. So the y value still has to be 0. That's the reason why the graph will shift to the left 3. Is that clear? Okay, let's look at, okay, if it's not clear, let's do this. So in y equals, I'm going to put in the absolute value of x. So in numbers, I have the absolute value and x. And then I'm going to put in also the absolute value of x plus 3. So we're not convinced that this graph will move to the left 3. So let's graph with the standard viewing window. I'm going to use 6. Here's the first graph, which is the absolute value. And here comes the absolute value of x plus 3. So this has 0, 0. This is negative 3, 0. a horizontal shift. The graph was shifted 3 units to the left. Say it again. Because it's a horizontal shift. So if you want to put in x3, if you put in 3, thinking that it will go to your right, 3 plus 3 will be 6, it will no longer be 0. But if x is -3, -3 plus 3 will be 0, and the graph does not shift anywhere else but left or right, which in this case will shift to your left. Now, if I want to add in the third graph, which is the absolute value of x minus 1, which I can. So I go to math and then absolute value, and in parentheses x minus 1, and graph again. You will see here's the third graph, which will be shifted 1 unit to the right. So this is x minus 1 in absolute value. This is the absolute value of x, and this is the absolute value of x plus 3. So coming back, that's what happens. When we change x into x plus a number, it has a horizontal shift to the left. When we change x into x minus a number, there is a horizontal shift to the right. Any questions?
Can we just remember the rule?
If you want. I prefer you thinking in terms of, okay, I need to keep the graph on the same axis, which is the x-axis. What should I do? Okay, it's definitely a shift to the left. If you want to remember the rule, that's fine too. You can say when I change x into x plus a number, it's a left shift. When I change x into x minus a number, it's a right shift. It's perfect. Yes? Go ahead.
Would it be the case for every absolute value? Because
Yes, for any absolute value and any function. So let me give another example. So if I want, for example, the... Oh, okay.
My question would it be the case because I'm thinking of x plus 3. If I just think about the absolute value of x plus 3, it's going to be x minus 3. So I know it's going to shift to the left.
That's fine. X plus 3 shifts to the...
X minus 1, the absolute value is going to be x plus 1. So it's going to shift to the right.
No, that's not allowed.
So that's my question.
No,
Would that
you
be
cannot
the
say
case for
that.
everything?
You can, yes, for all functions, and that's what I was getting ready to. It's a very good question. So if I want, for example, x plus 4 squared, and g of x, let's say I want x minus 4 squared, okay? So what is the base function in this case? Indeed. Where will this go? To the left, how many? Perfect. And where will this go? To the right. So the vertex here is 0, 0. When I change x into x plus 4, the graph shifts to the left 4. When I change x into x minus 4, it goes to the right 4. So this will happen for any function. So for each transformation, I will use different function for you to see different situations. Is that clear? Okay, let's look at number 2. Now f of x, let's say, is the square root of x plus 4, and g of x is the square root of x minus 2. Which base function did I use this time? I did use the square root of x. So this is the base function. Now the question is, what am I changing? Don't answer just yet. Am I changing anything that touches x? This is y, right? This is the y value. This is the x value. This is the y value. Or touches y, or changes y. So am I changing x, like I have here? X was changed to x plus 4. Or am I changing y? I'm changing y. This is outside. The positive 4 and the negative 2 do not touch x. They're outside of x. Okay? So I'm changing y. What type of transformation will this be? So when I graph the square root of x, oh, I didn't graph those. I did it with a calculator. Okay, that's fine. So this is the square root of x. What will happen when I want to graph the square root of x plus 4? Indeed, this goes up 4. So this is going to be the graph, the square root of x plus 4. What will happen here? It goes down 2. Here it is. the square root of x minus 2. This is a totally different story, and this is a vertical shift, not a horizontal shift. So what do we change when we go horizontally, left and right? We change x. What happens when we go up and down? We change y. Very good. Anything else? Other questions?
Boy,
Yes?
in the case of changing y, right? In the first case, we had x plus 4.
Oops, I'm sorry, I have 617 already. I'm sorry, my
In the first
apologies.
case, we had x plus 4.
I'm sorry?
I'm sorry, in the first one, we had x plus 4, correct? Why, are we not?
So you want to create g of x as the square root of x plus 4?
No,
Okay.
I'm thinking about the shift. I'm just thinking about the shift. In these other cases, we're moving that.
You mean talking about this?
No, I'm comparing that one to this. We're moving left or right.
I'm changing x into x plus 4. I'm changing y into y plus 4. This is the y value. This is the y plus 4 value. I'm not changing x. This would have been changing x from the square root of x to the square root of x plus 4. This is the square root of x plus 4, which is, this is the y value, plus 4. Is that better?